Let's begin the debugging questions. We'll continue what we have seen in yesterday's session, right? So I'll just go back to some interesting problems. Yeah, can you see this question? Let's solve this problem. I want you to please take pen and paper and try to see and solve this problem and guess the output. Okay, it's simple. It's a previous cognizant question again. Please see this question, try to guess the answer for this problem and you can reply in the chat box. It is very important. See, there are concepts hidden in these kind of problems. We are trying to make you learn the actual concept of programming through these problems. Okay, so please, can you make a guess? Any guess of the answer? I am expecting some answers. Okay, yeah, it won't execute. Yeah, let's see what is the answer for this problem. See, n value is given as 0. Again, always whenever you are solving a debugging problem in programming, you have to create a box like this and keep updating it here. You have to track the status of n. Okay, so see the first if, there are three simple if statements. There are simple if statement. They are all independent. Okay, it is something like this, right? They are all independent statements. So all three will execute. There is no else part here. Okay, so first one, if n plus plus, right? So n value, this is n plus plus. It is post. Post means you should not do it now. You should do it later. So first take the value of if of n. N is 0. So if of 0 means false. We won't execute. But before you go to the next if condition, there is a plus plus pending which you have to complete. Because of this, n becomes 1. Now if of 1, second one, if of 1, if of non-zero is true, it is true. Therefore I will print the value as true in the output. This will execute. Then third if condition, n value is still 1. If n is equal to 0, 1 is equal to 0, no, this condition is false. 1 is equal to 0, false. Therefore the answer is only true. Understood this? In if condition, n plus plus means it is post increment. You should not increment it. Okay, you have to take only n and give the output of that condition to the compiler. N plus plus you have to do it later. Plus plus part you have to do it later. Okay, so let's see another problem. This we have discussed. Again, all similar questions. Yes, please see this question. One point I would like to tell, generally we know in if condition we can write any condition or compound condition we can write. Okay, I mean to say you can write like this, if a greater than b is one example, or if you want to write compound condition, if a greater than b and a greater than c. Like this you can write a single condition. The whole expression will evaluate only one output, either true or false. This also, the whole expression will either evaluate either 0 or 1 as the output. But in this question what I have displayed here, if you can see, it is saying if of a minus minus and there is comma, minus minus a and a. There are three different expressions. So how will the compiler behave? Will it take, which one will it take for the conditional part? Please guess the answer for this problem. Very popularly asked these kind of questions. You please try this. Can you please guess the answer? I know it is a typical one. Generally in if condition we have only one condition or compound conditions, but here comma separated expressions are written. Programming expressions like a minus 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 a and a with comma separated. So what will happen? Which one compiler will take for making the decision? Okay, Jim, you are telling, okay, Jim Rogers. Let's see what is the answer for this. See, again, the important point here, when there are multiple statements like this, multiple independent statements like this in if condition, compiler will evaluate every expression from left to the right. It will evaluate everything from left to the right, and these are not we should not apply any rules. These are all independent expressions. Inside if condition, when you have a minus minus like this is an independent expression. It is not involved in any other programming statement. So when there is an independent expression, whether it is pre or whether it is post, you have to execute it. You should not apply any rule here of post and pre. Okay, so in such case, a value in memory, it is 2. So I have to execute from left to the right. So a minus minus, so I have to reduce it, it becomes 1. Next minus minus a, I have to reduce it, it becomes 0. Then only a, that is 0. Now once all the expressions are evaluated, compiler will take a decision of if or else part based on the final value here. What is there here? Only a. What is the value of a? 0. It means it is if of 0. So false, it goes to Jim Rogers. Okay, it goes to else part, right? So let's see. Same is this expression again. Similar problem, we are having I0, I equal to 0, j equal to 1, k equal to 0. In the if condition, I wrote plus plus k, comma j, comma I plus plus. Though they are different variables, what will happen? Compiler will definitely execute every expression. See, this is plus plus k is a pre-increment. So increment it, k becomes 1. J, only independent j, no change in the value. Here it is I plus plus, don't apply your post increment rule. They are all independent expressions inside if condition, because there is a comma separated value. There is a comma value here, right? Therefore, I plus plus has to be executed. Because of this, it becomes 1, and therefore the answer will be 1 1 1. Okay, I hope you understood. When in if condition, if there are multiple expressions like this, everything should be executed independently and without applying any rules of post and pre increment. Okay, let's see some questions on switch case. We have already seen this problem. Anything to discuss? We have seen this. I'll just see for some time. Yeah. So two problems are there in this question. You can just see what is the output of this. Can you guess the output of this problem? There are two important points in this question. See, there is switch of 3 and there is a printf statement. This is printf in double quotes doing something. Okay, then case 1 and then case 4/3, no default, nothing. So what is the output of this? Can you guess the output of this problem? Any guess of the output? What will happen here? Okay, let's see. So two important points here. First one, generally switch case, in switch off, here I can write any expression, I can write any programming statement. Ultimately, this expression or programming statement should yield me integer constant always. It should return me, if you see something, see this printf nit, this is printf will return a number 3 to switch. It is ultimately giving me an integer number. Okay, if you see some other, yes, we have seen this problem yesterday. Printf do, it is printing 2 characters, so this printf will return a number 2 to the switch. So it should generate me an integer constant. first point. And when it comes to the case, here we write, no, we can write here case expression again. Here also you can write any expression. Okay, you can write here 4 by 2, you can write here case 1 into 3 colon, like this you can write mathematical expressions, but the output of that expression should yield an integer constant, that is the rule. However, if somebody writes here case 4 by 3, what is the value of this 4 by 3? It is somewhere around 1.2 something or 1.1 some change, right? So this is a floating point number, not an integer, but compiler will automatically convert this value to 1. It will round off it to integer. Okay, it will round off it to integer. So the important points here, if you see, this is already case 1. This value is also yielding a value 1. So suppose I am passing 1 here, switch off 1. Compiler is confused which expression to choose. Okay, case 1 and case 1. There are two case matching with same number 1. This will throw an error, ambiguity error, because it is having confusion. I do not know which one to choose. That is first point here. Second point here, I have written a statement, printf doing, in double quotes, doing something, but it is outside the case. Again, in switch case, inside switch, you have to write statements only with case and default. We can write only statements after case. You cannot write anything above the case. If you are writing any statement above the case, this is not an error. Compiler will not execute that particular statement. So in the output, even if this was, suppose, let's say if this was case 3, a valid program, if this was the case, if this was case 1 and case 3, since we are passing 3, this will be coming as output. Case 3 executed will be the output, because that is matching. Though there is a matching case, valid programming statement is there in the program. Okay, so this printf doing nothing or doing something will not be executed. Okay, that is the second point here. I hope you understood. For this problem, it will throw ambiguity error, though there is no matching case, but keeping two cases as same value is an error. This is not accepted. Okay, I hope it's clear. Let's see some typical problems. These are all again simple problems on switch case. This we have seen. Yeah, see this statement. Please see this and try to guess the output of this statement. You see here, num value is 0. If I have 3 statements, then I have switch case, and then there is a default. So there is case 2, there is case 1 and default. Can you guess the output of this? Any guess of the output? Case 1. Okay, let's see the answer for this. See, again, after if there is no open close, it means its next statement is the body of if, and next statement is a switch. So this full is a switch. Okay, there is one close bracket missing. This full is a switch. So the statement is like this: if of something, open bracket, close. Here there is switch. So this is a single, this whole switch is under this if. Okay, now let's see. Num value, n value is 0 initially. In if condition, there are 3 independent statements. Num plus plus, it becomes 1. Num minus minus, it becomes 0. Plus plus num, it becomes 1. So if of, it is 1. If of 1 means true. Then you enter into the switch. Now in switch, what is happening? Value of n is 1. Current value of n is 1. So this is 1. So case 1 is matching, it will go. Right? So answer will be case 1. This we have seen. This also we have seen. Similar problems, I am just discussing those things. Yeah, please do this problem. Please see this array of 3, I is 0. If I is less than 3, a of I equal to plus plus I. 3 times you have to repeat this because I value is 0. After that I am printing those values. Can you guess the output of this problem? Any guess of the output? What will it print? What are those for I 0, I less than 3, I plus plus? I am printing the values of the array. So what could be those 3 values? One, two, three, 0, 1, 2, 0, 1, 2. Okay, let's see the answer for this. Yeah, see, you should be very careful when you are doing it. See, whenever you are seeing a statement C equal to A plus B, first we are calculating A plus B, then we are assigning it to C. This is very simple thing. That logic you have to use it here. See, array A, it has 3 memory locations 0, 1, 2, and I value is initially given as 0. While 0 less than 3, true. Come here, a of I equal to plus plus I. So first you do plus plus I, then assign that value to here, right? So what is plus plus I? I value becomes 1. Now what is the expression here? A of I. So a of 1 is equal to 1. So this becomes 1. Okay, not 0. Be careful. That's why this problem is given here. I told you, no, C equal to A plus B means first you have to complete A plus B part, then you have to assign the value. So I am incrementing value of I first only. Plus plus I, it is becoming 1. Now the current value of I is 1. So therefore A of I means A of 1 equal to this value is 1. So this value becomes 1. Next for loop, it goes up. So 1 less than 3, it is true. So plus plus I becomes 2. Therefore A of 2 is equal to 2. I write it here. Again from here I will go back to condition. This is I value is 2, 2 less than 3, yes, true. It is true. But what is happening here? A of 2 plus plus I means it becoming 3. A of 3 is equal to 3. A of 3 is equal to 3. So this is going beyond, but C compiler will not throw you any error. C compiler will not throw any error for this statement. Okay, that's it. Next it will become 3 less than 3, it will fail, it will come out of that. Okay, so what are the values I have loaded? I have not filled anything in this particular box. Here I loaded 1, here I loaded 2. That's it. Now when I come and print it, I am printing I 0, I less than 3, I plus plus, percentile D hyphen hyphen A of I. So A of 0 means there is nothing, so it is garbage value. Then hyphen hyphen A of 1 is 1, hyphen hyphen 2. This is the answer. 2 hyphen hyphen will come. Okay, this is the answer. Be careful, in the first box we are not filling anything, it will be garbage value. Okay, and in the third case, when we are trying to know A of 3 equal to 3, C compiler will not throw error because it is the immediate next box after my memory allotment. After I allocate memory, it is the next box, immediate next box. So for that one box, it compiler will not throw error. Okay, so this is possible, it will go and store there, but we are not accessing that. So it is not a problem. So the output is garbage 1 and 2. Okay, I hope it is clear for you. I hope you understood why it is garbage 1, 2. Any doubts in this? Any queries? Yes. Let's go to the next problem. Yes, one more interesting problem. A plus 1 ampersand a plus 1. So A of 3 rows 4 columns. So the matrix is something like this. Let me draw that matrix. 3 rows and 4 columns. Zero, 1, 2, 0, 1, 2, 3, and the values are given 1, 2, 3, 4, 4, 3, 2, 1, 7, 8, 9, 0. Okay, and the problem says integer occupies 2 bytes. Integer occupies 2 bytes, and the array begins at 6, 5, 4, 7, 2. So the memory of this box, okay, the memory of this box is 6, 5, 4, 7, 2 is the memory. So if I write in shortcut, it is 74, it is 76, 78, 80, 82, 84, 86, 88, 90, 92, 94. I have written last 2 digits of the address. This is the addressing scheme. Now they are asking you to print percentile u means unsigned int. Percentile u means unsigned int, means a positive number. So a plus 1 ampersand a plus 1, what is the value? So what is the output of this? Matrix is here. I have written the addresses also. Can you guess the output? What could be the answer? A plus 1 means what? A is the name of the array. So what will it print when I say a plus 1? No, I am addressing is 65472, 74, 78, 76, like that addresses. Any guess of the answer, please? Six 54, 72, 74, 72. Okay, let's see the answer. Maybe there is some a plus 195. Okay, let me clear the concept. See, whenever you have let's take a simple example. Let me go to another slide. Yeah, so let me take a of int a of 3. A simple array is there. Okay, let me write the values also. Some 1, 2, 3. So there is an array which contains the values, 3 values, 1, 2, 3. This is the name of the array. Let's say starting address is 1000. This will be 1004, 1008. If integer occupies 4 bytes, 4 bytes, that will be clearly given in the question. Okay, so 4 bytes. This will be the addressing scheme. Now, when I write printf percentile d comma a is the name of the array. When you are giving the name of the array, it will print the base address. So output will be 1000. Okay, if you are writing printf percentile d comma a of 1, sorry, a of 0, then it is 1. or if you are writing printf star a, if you are writing star a, that is the name of a means 1000, star a means value at 1000, that is 1. So this also give me 1. So whenever you are giving the name of the array, it will give the base address, starting address of the array. This is for a single dimension array. Now let us take the second case, int a of some 3 3, and I have, let us say I have some values here. So this is a 3 by 3 matrix. So there are some values 10, 20, 30, 40, 50, some values are there. Okay, indexing is 0, 1, 2, 0, 1, 2. This is a of 3 3. Okay, now when I write printf %d printf of a, let's say the starting address is 1000 for this. Okay, let's say the starting address is 1000. So this will be 1004, 1008, 1012, 16, 1020, 1024, 1028 and 1032. Now when I write printf a, only printf of a, what is the a means? It is the name of the array. When you are giving the name of the array, it will print the base address, that is 1000. But if you write printf of a plus 1, okay, in 2 dimension or 3 dimension array, when you write printf of a plus 1, okay, it will not go, a means 1000, 1000 plus 1 means the next location, it will not go to 1004. When it is a 2 dimensional or a 3 dimensional array, a is pointing here, a plus 1 will be pointing here, a plus 2 will be pointing here. Okay, so a plus 1 means the answer will be 1012. This, it is a plus 1 is pointing to this row, the whole row. A is pointing to the whole row, first row. A plus 1 is pointing to second one, a plus 2 is pointing to the third one. So when you give only a, it is 1000. When you give a plus 1, it is the starting address of the second row, that is 1012. If I give pf of a plus 2, then it is 1024, this address, starting address of this third block, 1024, that will be given as the output. This is the case with the 2 dimension or 3 dimension, whatever dimension of the array. Okay, I hope you understood now. Now let's go back here. So when I ask you a plus 1, what is the answer now? The base address is 65472. So a plus 1 means it is pointing to the this record. So what is the starting address here? 65480 is the answer for this expression a plus 1. Okay, the answer is 65480 because 80 is the starting address of the second record. Okay, now what is ampersand a plus 1? What is ampersand a plus 1? Let me discuss this in this slide. Okay, so single dimension array again, int a of 5. Let's say I have 5 values here. So I will draw that array here. Let's say I have some values 15, 16, 17, 18, 19. Let's take 100 address as simple numbers 104, 108, 112 and 116. These are some simple numbers. This is a value. Okay, now very important point here. This is a very popularly asked question in almost all exams, ampersand a plus 1 and a plus 1. If you see here, if I print if of a, printf of a, what is the answer? A is the name of the array, therefore address, base address. Okay, here if I write printf a plus 1, this is a single dimensional array. So a plus 1 means a is pointing to this block, a plus 1 will point to the second block. So what is second block address? It will give me 104. Why? There is no dimension. A plus 1 will point to second small box here, 104. Okay, now if I write printf of ampersand a, ampersand a here, understand the difference, a and ampersand a. When you say only a, it is pointing to the, a is pointing only to the address of this block. A is pointing to the address of only this first small box. Ampersand a is pointing to the address of this entire block, starting address of this entire block. That is the difference between a and ampersand a in arrays. A is pointing only to the small box here, that is address of first block, that is 100. ampersand A is pointing to the starting address of the entire memory allocation. Again, that is 100, but meaning is different. A is pointing only to the small box, ampersand A is pointing to the whole box. Starting address of both is 100. Now, keeping that in mind, now when you see my point here, what I am talking here, if I say I want A plus 1, since A is pointing here, A plus 1 is 104, whereas ampersand A plus 1, ampersand A is pointing to the whole block, plus 1 means its next block starting address. So, in this case it will be 120. Why? Ampersand A is pointing to the entire block, it is pointing to this entire block. What is the static address? 100, same 100. But when you say plus 1, it is talking about some block after this memory. From here there might be some partition. So, this block beginning address, that is 120. Is this point clear? Difference between A and ampersand A? Yes? Is it clear? Difference between A and ampersand A? Right? A plus 1 is pointing to the next block, ampersand A plus 1 is pointing to the whole next block. Okay. Now, keeping that in mind, let us come back to our problem. Here when I am asking A plus 1, that is pointing to the second row starting address 80. When I talk about ampersand A plus 1, here ampersand A is representing the address of the entire starting block. So, ampersand A value is same, the base address 65472. When I say ampersand A plus 1, where is this block ending? It is ending here. So, it is ending here 94. So, it is ending at 65494 plus 2 bytes. So, this value will be 65496. After this matrix end, the next starting address will be 65496. So, ampersand A plus 1 is pointing to 65496. Okay. So, therefore, the answer for this problem will be A plus 1 means 65480, ampersand A plus 1 means 65496. Okay. This is output of this problem. Is it clear? Any doubts in this? Please let me know. If you want me to repeat it, I will repeat it. Especially when you write GATE exam, you will have a lot of questions like this. If you can see previous, I think this is a previous GATE question. You can find so many questions in GATE computer science of this model. Okay, right. Let us see. Again, I will draw that box. It is a 3 cross 4 matrix. So, I am drawing that. Right. So, I will just write the addresses. We do not need values here. We are talking only about the addresses. So, this address is 654,472. I am writing the shortcut of that. This is, and it is saying integer is occupying 2 bytes. So, every block will be 74, 476, 478, 480, 482, 84, 86, 88, 90, 92, 94. Okay. So, this is the addresses of each block. When I say A plus 1, A is pointing to the first row, A plus 1 will point to the second row, A plus 2 will point to the third row. This is in case of 2-dimensional array. So, when I am printing A plus 1, what is A? A value is address, that is 476, 54, 72. This is the address of the entire first row. When I say plus 1, it is coming here. So, what is the starting address of that? 480. So, A plus 1 will be 65480. But what is ampersand A plus 1? Ampersand A means it is pointing to the starting address of the entire memory block. How much memory compiler is allocating? See, when you write A34, compiler will directly at a time, single time, it will allocate this box. So, ampersand A is pointing to the starting address of this entire block, that is 65472. When I write ampersand A plus 1, it means after this memory block is ending here at 94, its next beginning address, that is 65496. Difference between A and ampersand A points to the first block starting address or the first record starting address. A plus 1 points to the second row starting address. Ampersand A points to the whole block starting address. So when I say plus 1, the next block starting address. We do not know how many elements are there in the next block of memory allocation, but I can identify the address of that. Why? The ending address plus 2 bytes, that is 65496. Okay. Again, this is some problem. Yeah, please see this question. Please try to see all these array problem or pointer problem. You should take pen and paper and solve it. Otherwise, you cannot. Please see this question. Try to guess the answer of this. Carefully do this and guess the answer. Do this and reply your answer in the chat box. No guess? No guess of the answer? Are you solving it? Yes. Please take pen and paper and try to answer it. At least some rough answer. Okay, it seems no answer. Okay, let me attempt. Okay, let's see the answer. It seems to be little typical. Yeah. Okay, only one attempt. Yeah, fine, easy. Let's see. See, array X contains values 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so indexing I'll write here 0, 1, 2, 3, 4, 5, 6, 7. Okay, you should be very careful while doing this, right? So see, I equal to 2, I am writing here x of I is equal to x of I, right? So I equal to 2, 2 less than 6, yes. So what is x of 2 value? I value is 2 now, I value is 2. What is x of 2 value? X of 2 means 3, this is 3, equal to, what is x of I? I is 2. So x of 2 I have to make it, I value is 2, x of I means x of 2 means 3. So x of 3 equal to 3 you have to do, x of 3 equal to 3. So because of this 4, this will become 3. First loop over. Next I plus plus, so I becomes 3. Okay, now again I becomes 3. So what is this expression? X of 3. X of 3 means this box. What is the value? 3. Again x of I is 3. X of I means x of 3. X of 3 is again 3. So you have to write here x of 3 equal to 3. No change of this. Then I becomes 4. Okay, I becomes 4. So now what is x of 4? X of 4 value is this one, that is 5. And here also this is x of I. X of I value, that is I value is 4. Put here x of 4. X of 4. What is x of 4 value? It is 5. So therefore x of 5 is equal to 5. Where is x of 5? This one. It should become 5. Now again I plus plus, I becomes 5. Okay. So when I becomes 5, what is x of 5 value? See the memory block, it is 5. So this value is equal to 5. Now again x of I is 5, x of 5 is 5, so this is 5. So x of 5 equal to 5 should be there. We already have it 5, no change in that. Now the third iteration, I becomes 6 and 6 is less than 6, plus plus I write. So 6 is less than 6, no, it failed, you have to come out, right? So answer 1, 2, 3, 3, 5, 5, 7, 8. That's how the array has changed. 1, 2, 3, 3, 5, 5, 7, 8. Correct. Understood, right? You should be careful while doing it. Always do the left hand side first, then you go for this expression on the right hand side. So this can be solved easily if you are tracking I value like this. Is it clear? Any doubts in this? Any doubts in this question? Okay. Strings. These things. This is an interesting part. Let's see this. This can be this concept exists in array also. I should have that problem. Let me see. No. So let's see that problem. I will repeat that point and then we'll see this problem. Yeah. So generally in array indexing, if you have values like this, let's say 10, 20, this is 0, 1, 2, 3, 4. We write indexing as a of I. This could be written as I of a also. Okay, a of I is equal to I of a. We can write it like this. So even if I give a of 2 or 2 of a, the answer is same here, that is 30, right? So now here if you see a of 0 of ARR means it is ARR of 0. Okay, then in the second expression if you see, I am having 2a plus 2. So this is something like I a plus j. In this case, what is the equivalent expression here? We know a of I means I of a, but here I wrote I a plus j is extra j is there. So its meaning is I into j, a of I into j. That is the meaning of this expression. Okay, you have to multiply it with j. Now can you guess the output of this problem? Can you guess the output? str means percentile d percentile c. Then 0 of a means it is a of 0. This is capital C. Yeah, you can write this in a string, right? You can give here C, then a space, then L, A, N, G, U, and so on. So 0, 1, 2, 3, 4, so on. Indexing for string. Any guess? Yeah, so let's see. Capital C is at the indexing 0. So 0 of A is equivalent to A of 0. Now I have put here percentile D, but it's a character. So when you are giving a character and printing percentile D, it will print the corresponding ASCII value. So for can you tell me what is the ASCII value of capital A? Small a and capital A ASCII values, can you please tell? Yes. So for capital A it is 67, therefore for C will be 69. So the first output is 69. Next I am asking here percentile C. So I am printing a character 2A of, so the meaning of this expression 2A plus 2 means this is A of 4, 2 into 2. So which one is A of 4? See, A of 4 is N, 0, 1, 2, 3, 4. So 69 and N is the answer for this problem. Okay, the only point to highlight here was array indexing. You can write I of A or even A of I, both will work together. However, if there is some complex expression like this, I of A plus J is written, its meaning is A of I into J. Okay, you can try this, execute and see what is the output for that. Is it clear? Oh, C, right. A starts from 65, so C it is 67. Right. These are all small conditions. I'm just looking for some. Yeah. So can you please do this? Take pen and paper and try to solve this problem. Can you please solve this? Take pen and paper and try to guess this. See, don't don't tell me the entire answer. Just tell till here, because we are having a printf statement here. These two expressions you evaluate and tell me what is output of this printf. What is output of first printf? Small h, capital H. Okay, H. Let's see what's happening here. See, S of plus plus I. So this T is 0 indexing, H is 1, E is 2, and so on. Okay, so I value is 0, I value is 0. S of plus plus I means I will become 1, S of 1, it's very clear, it is capital H. So I'll write the output here H. Okay. In continuation, we have another expression here. I value is currently 1. Then there is second statement ch equal to s of I plus plus. In this case, what will happen? Plus plus I will not do it, I will do it later. S of I value is 1. S of 1 means again capital H. So this H will come, but before you print that, you have to increment the value of I. Because of this, I becomes 2. Next come to the third statement. Okay, ch of I plus plus of s. I became 2. I am talking about the third expression here, I plus plus of s. So this is equal to s of I plus plus, because this plus plus is attached as post increment for this I. So we cannot skip this. We have to take the whole expression inside. Now again, what will happen? Plus plus I will do it later. S of I value is 2. S of 2 means E. And then I have to increment. So I becomes 3 in this time. I became 3. Now the last expression, you should be very careful here. See, ch equal to plus plus I of s. Can you tell me what will happen here? I value is 3 now. So what is the output of the final printf statement? Ch equal to plus plus I of s. Any guess? Again capital H. Okay, let's see. See, this time this plus plus is pre-increment. So this cannot be taken inside. Only I. This can be taken here. This is equivalent to S of I. Previously we took this whole inside because we cannot leave any character. You have to take this I only has to go inside. But this plus plus I cannot leave it. It is attached with this. But when it coming to this expression, this plus plus is independent of this value. So it is plus plus S of I. So what is I value? 3. What is S of 3? 0, 1, 2, 3. So this is null. Here there is a null character, right? So null character ASCII value is 0. So plus plus of that means it becomes 1. Okay, sorry, this is I am printing percentile C here. So it is null character there. So plus plus of that means it is exclamatory. So this is the value HHE and exclamatory. Why? Because the ASCII value at 1 is exclamatory, at 0 it is null. Okay, so the overall point here is to say you that when it is I plus plus of s, this whole has to go inside, whereas when it is plus plus I of s, it is simply s of I. Okay, right? This is the answer for this problem. One more question we will see and we will wind up for today. We have seen this looping statement. This is again to waste our time. We have some questions like this. Then yes, see this static variable. Let's see this one problem. Interesting question on static variables. This one problem we will solve and then we'll wind up. Please see this question. Two times I am calling the function fun. So what will it print? 2 and 6. See, num is a global variable and also it is defined as a static variable in the function fun. Okay, let's see the output of this. Here n is global. Okay, I will just write it here. N, I'll just put this tag global and 5. Okay, this is assigned. Now enter, I call the function fun. This is the control shift to function. Here I am creating another local variable inside function. So inside the function I am having a local variable fun with num value as 2. Okay, this n is a static variable. Printf num, so this will point to this local variable. So answer is 2. Then num plus plus, so this will become 3. That's it. From there I go back to from where I called it. So again second time I am calling fun. When I call this fun, it will come inside again static int num equal to 2. This time this statement won't be executed. The point here is static variables can be initialized only once. You cannot again assign value 2 to this variable. If it is defined as a static variable, you cannot assign 2 to this variable. So second time this compiler will skip this statement. Second time compiler will skip this statement. So %d num means it will point to this 3. So it will print 3 and then make this num to 4. That's a 2 time over answer. So this is just to confuse you. There is nothing, no impact of this variable. Answer is 2, 3. Static variables will not be reinitialized. So second time when you are calling the function, that statement static int num equal to 2 will not be executed. Okay, right? So that's it for today. We will continue this in next class. So you can refer to the video which I have shared.